Hi there. This is a problem set in projectile motion, and this is a preparatory worksheet, and I'm going to help you, give you some hints on how to solve some of these. Question 1, how long would it take for an object to fall 10 meters? Well, falling implies that velocity initial is 0. Distance is going to be 10 meters. Acceleration is going to be as a result of gravity, and we're looking for time. And the real popular formula, we love this one, is distance is equal to VIT plus 1/2 AT squared, which is why it's so important to identify initial velocity as 0, because then we get rid of that. So distance equals 1/2 AT squared. In this equation we know distance, we know acceleration, and we're looking for time. So we get rid of everything that isn't time, so 2 times distance is 1/2, or is GT squared. 2 times distance divided by G is T squared, and the square root of 2 times distance divided by G is equal to T. You've got distance, you know G, and you can get the square root. That problem is solved. The next question, how far, so we're looking for distance, when an object fall, if it fell, so velocity initial is 0, and time is 3.4 seconds. And it's falling, so acceleration is g. Well, that's our equation. Distance equals VIT plus 1/2 AT squared. Velocity initial is 0, so distance is equal to 1/2 AT squared. And all you have to do is make sure you square time, 3.4 seconds, multiply it by g, and don't forget to take half of it to get the correct answer. Question 3, how long would it take for an object to fall 15 meters? That's exactly like question 1, with a slight distance difference. Question 4. Several different aspects of it. If a ball is thrown upwards with a velocity of 45 meters per second, so velocity initial is 45 meters per second, how high in the air will it go? Well, it'll keep going up until it has a velocity final equal to 0. And you're looking for the distance. Well, a couple of different ways of doing this particular problem. I'm actually going to go to part 2. I'm going to find out how much time it'll take to reach that height. Well, I know that its change in velocity is going to be 45 meters per second. And it's going to change velocity because of the acceleration due to gravity. And so the time can be found using, well, this one. Acceleration is change in velocity over time. Therefore, time is equal to change in velocity divided by the acceleration. So that'll tell me how much time it takes to do that. If I apply that time to this equation here, now I know time, I could solve it. Or I could do this equation. Velocity final squared equals velocity initial squared plus 2AD. Velocity final squared is 0, so I can subtract velocity initial squared. So velocity initial squared is equal to 2AD. We're using acceleration due to gravity. Keep in mind, if we're going to throw it up, then acceleration is negative, so that takes care of the negative. So velocity initial squared divided by 2g gives me the distance it takes to go up. And now this question, how fast will the ball be going when it lands back at the original starting height? Well, now we really need the information. We could do distance. We know velocity initial is going to be 0 because it's going to be at the top of its path. We're looking for velocity final. And look at this. Velocity final squared equals velocity initial squared plus 2 acceleration times distance. We know distance from the first part of the problem. We know acceleration due to gravity. Initial velocity is 0. And so velocity final would simply be the square root of 2 acceleration times distance. Question 5. A gun is shot straight up into the air as part of one of those celebrations you see whenever cowboys want to celebrate anything. See, this is a problem in some parts of the country where shooting guns up in the air is still a way to celebrate New Year's Eve and things like that. Eventually those bullets come back down. The bullet leaves the gun with a muzzle velocity of 1,500 meters per second. So velocity initial is 1,500 meters per second. How long will it be before the cowboys need to worry about those bullets landing on top of them? So we're looking for time. Well, let's do the time it takes for the ball to go up. Well, the velocity final, again, is going to be 0 when it reaches the top of its path. So the change in velocity is going to be velocity final minus velocity initial. The change in velocity is also going to be 1,500 meters per second under the influence of the acceleration due to gravity. And so this is a simple equation with a little trick to it. If acceleration is change in velocity over time, then time is change in velocity over acceleration. The time it takes to go up, change in velocity over acceleration. And based on the fact that it's going to be going up a distance and falling the exact same distance, we can simply say that the total time in the air is equal to 2 times the time up. So take this number, multiply it by 2. That tells you how long that bullet's going to be in the air.